Hello, algebra students. Okay, so now we're still looking at matrices. Now we're looking at multiplying matrices. I'm going to ignore this for a second. We'll just think about a problem like this. Let's say, think about who does the food shopping in your house. Who goes to the grocery store and gets the groceries? Okay, so let's imagine a situation where, mom or dad or grandma, grandpa, uncle, aunt, they go food shopping once a week. And so they go shopping once a week. And in that week, they get, let's say, one carton of milk, one gallon of milk. They might get, let's see, what else? Two things of eggs, dozen eggs, and one loaf of bread. So these represent milk, eggs, and bread. Every time they go food shopping, they get one of those. They don't even think about it. If you go with them, they'll say, okay, go grab a gallon of milk. We always go food shopping. And that's how I know I shop. I kind of have a pattern. What do I do every day? What's a particular one I make sure I do? So my one here I'm saying is I always get, let's say, imagine 1 gallon of milk, 2 cartons of eggs, and 1 loaf of bread. But let's say for a second, I go shopping once a week. I'm spending too much time in the grocery store. I don't want to go shopping once a week. I want to go shopping once a month. Okay, so what do I need? Well, if this is what I'm getting every week, I would think to myself, well, there's 4 weeks in a month. So since I have 4 weeks in a month, I'm going to take this and see how many I should get when I go shopping. So when I go shopping, as it turns out, it seems like I have a very big family here. 4 times 1 for the milk is 4 times 1. For the eggs, it's 4 times 2. And then finally for the loaf of bread, it's 4 times 1. So shopping for my big family here. Now I can look at my grocery list for this month and say, well, I have to buy 4 gallons of milk every month. I have to buy 8 cartons of eggs. And I have to buy 4 loaves of bread. So it's a very simple way to keep things. Now, I don't add these up because these are all different, because these don't represent anything but milk. This represents eggs and this represents bread. I don't push them together, I don't add them, I don't subtract them, I just leave them as is. I leave that matrix as is, so when I go on my monthly shopping now for my giant family, this is what I buy. 4 gallons of milk, 8 cartons of eggs, and 4 loaves of bread. Okay, so that's all we have to do. So let's go through this again. Let's do this problem over here, another multiplication of matrices. If you think about it, it kind of reminds me a little bit of distributive property. Okay? In my mind, you could almost do this. Right? Do the rainbows. I'm going to tell you, do it if you're comfortable with the last part. So look at what I do and then make your decision, because I'm not going to say this is definitely the way to do it. Okay? Because if you do it this way, you'll probably get it right, but some people might think back to distributive property, and when you're done with distributive property, you combine like terms. You do not combine like terms, because these aren't really like terms. Right? Remember, this is milk, eggs, and bread. You can't combine them. You can't say, well, I need 3 loaves of bread, and, they're all out of, 3 gallons of milk, and they're all out of bread, so I just combine 8 and just get 8 gallons of milk instead. No, you don't do that. So, let's do this very cleanly. 2, negative 2, everything is getting multiplied by this negative 2, times negative 3. The middle one is 7.1 times, negative 2 times 7.1. And then finally, negative 2 times 5. I put those all in my trusty calculator. And I go negative 2 times 3. Oh, negative 2 times negative 3, excuse me. Be careful. And I get 6. The middle number is negative 2 times 7.1. Remember, use the Desmos scientific calculator if you need it. And our middle number is negative 2 times 5, and I kind of know that one in my head. It'll be negative 10. And that's my matrix. Now, the desire might be in your head to combine these numbers. Don't do that. Leave it alone. When you're working with matrices, they stay in the same thing. Remember, milk, eggs, bread. You can't combine them. Okay? You can't substitute one for the other. They're not the same thing. So you leave them. They're not like terms. Okay? So there's our thing. So one more. Let's make them one a little bit tougher. In the PowerPoint slides, you'll see this one. Of course, I just lost the PowerPoint slide. Hold on. Okay, so there's this one in the PowerPoint slide for negative 1.5, 1, and negative 6. Now I'm going to do the big, long method. If you know in your head. See, so now, if you're thinking distributive property, it gets a little weird because you have to multiply by this. Then how do you draw the other rainbows? Underneath? I don't know. I'm not even going to bother with that. So what I'm going to do is this. Okay? I'm going to take all my numbers. There we go. I'm going to keep this 3. I'm going to make this 3 reddish, right? You see how it's red? Okay, watch this. So, new formula. My new matrix, the big one. I'm going to go 3 times all of these numbers. So then I'm going to put in all the numbers. 4. Keep position 1, right? This is position 1, 2, 3, 4. You name them how you like, A, B, C, D if you want. But they stay in the same position. 3 times negative 1.5. 3 times 1. And 3 times negative 6. Now finally, our answer. Let's do our answer in, let's say, black. Because we're finally done. We just need our calculator for all this, right? So here we go. I'm going to draw my new matrix. I hope you actually see that this is not very complicated. When you learn more and more about it, it gets more and more complicated. But this is as far as algebra goes into it. 3 times 4 is 12. Let's do position 2. 3 times negative 1.5 is negative 4.5. Position 3 is 3 times 1 is 3. And position 4 is 3 times negative 6, negative 18. Now what you're going to see here is that we keep the same matrix. It's still a 2 by 2 matrix, the answer. Okay, so we're multiplying this whole matrix by this number. And this is as far as we go. There's other things that people do with matrices that gets very, very, very complicated and weird. But fortunately, in Algebra 1, this is about as complicated and weird as it gets. Okay, guys, I want you to have a good day. I'll talk to you later. Bye-bye.